So I wanted to talk about why I went to augmented reality, and kind of, so it's a little bit of a fire hose because I need to show you a sweep of about 10 years of research. But hopefully you see kind of how each step was motivated and what kind of I got out of each step. So first, the context of my research is around complex systems and agent-based modeling. And sort of simply what that is in the world, there are lots of systems where micro components interact to create macro phenomena. So the atoms or the molecules in a gas bump into each other, and at the aggregate level, there's pressure. Wolves and sheep chase each other, and at the aggregate level, there are population dynamics. Or cars try to get to where they're going at particular times of day, and at the aggregate level, there are traffic jams. And people are really bad at reasoning about these kinds of systems. And the math that has traditionally been used for it is really opaque and advanced. So this is a terrible, it's a really urgent situation or setting for people to reason well. And people when they think about the whole aggregate, they think really badly. On the other hand, people, it's really easy to imagine bouncing into other third graders like molecules in a gas, or chasing a sheep if you're a wolf, or being in traffic. And so if we can leverage ways that people think at what we call the agent level for aggregate reasoning, we get a big payoff. And so so agent-based modeling does that. It uses computational tools to let you write little rules for the agents, and then let thousands of them run, and then you get to see the emergent phenomena. So it's a really important tool for people to reason about the key systems in their lives. But it's hard, and it involves programming. The NetLogo environment is accessible, and it's designed in such a way that I've used it with middle schoolers, and at the same time, the Santa Fe Institute for Complexity uses it as their main tool. So it can be your first programming environment, and it can be a thing you can publish research in the field in. But it's still programming. So what I do is I use an activity called a participatory simulation to get into the door with modeling with agents. And that kind of simulation involves a group of learners being the system that they want to understand. So it's very theatrical. You enact a system, and then we use technology enhancement so that your enacting actually creates the phenomena. And then a key thing for me is that it's got to be an entry experience, so that you actually get into thinking about agents with NetLogo. So my first step was to make participatory simulations widely available. So here's the really low-tech looking thing that has a whole bunch of high tech behind it. What's going on here is 30 people with cell phones or laptops are each controlling an avatar in this space, and the community has a disease. In the first version, that white cactus is the one that first got the disease, and you can tell the disease is symptomatic. You can tell when you're sick by having a red dot. So there's a bunch of reasoning about the spread of disease that can happen by being the population that gets it. But what really starts to lead to kind of unique experiences that the group can use themselves as the basis for an experiment. So here is the end of a session where a group has first experimented with what would be different if it wasn't symptomatic. You couldn't tell whether the other people were sick, for example, or if you could recover. So we got to a point where we had a disease that was in the population at a stable level, and then we started having town meetings about policies for how we could mitigate the spread. So we were trying to flatten the curve. We were trying to reduce spread, and then we were thinking about this explicitly in terms of COVID. We also introduced androids, these gray guys, that were non-compliant. So your policy had to survive a percentage of the population being non-compliant. So here you've got a virtual space where the simulation is going on and people are controlling an avatar in it. But what I wanted to do was think about how that virtual space of the simulation could be the physical space that we were in. So the next step was to create these wireless and wearable computers, so that now the classroom is the space where you don't have avatars, you are your avatar, and you're interacting with other people. The advantage here was that that we could, so we captured, we did kind of marketplace thing. You were trying to find something out, and we captured the network of interactions over time, which we then could play the disease on. So we said, here we have, looks like this center person is the most connected. This layout shows who's most central. And so if they got sick first, the disease would spread in a different way than if one of the peripheral actors got sick. And since the people are people, they can interact according to rules that are about their lives. So on the left, we have people interacting only if they have another class together. And on the right, they're interacting only if they are friends on social media. And the disease obviously spreads in different ways, and the network dynamics come to the fore through that embodiment. So great. So now the body's cool, but we don't have a real-time connection between the participatory simulation and the bodies, and that's what's next. So here we have a bunch of ninth graders who have been designers for us for the last semester on these kinds of embodied real-time participatory simulations. And they're getting ready to play, they're play testing the thing that they made for middle school audience. The things they're wearing on their heads are little plastic helmets that have a location tracker. That tracker it's down to like 10 centimeter accuracy, and in real time feeds their location into the simulation. So here's, here are their, I'll jump directly to the picture. So here's what it looks like in action. So as they move, the projected display is controlled. So in this case, they are, the red guys are polluting the aquatic ecosystem, and the green guys are cleaning up. And the green guys, right about this person, the person in the back just said, it's so much harder to clean than it is to pollute. And so this was like the victory for the playtest, for the ninth grade playtest, was they really wanted students to experience an asymmetric relationship between polluting and cleaning. So here are two others. Again, the project here is a group of ninth graders who are studying ecosystems and sustainability, want to teach what they've learned and what they're passionate about to a middle school audience. So they worked with us for a semester to create these augmented reality embodied participatory simulations, and then to play test them, and then to run them with the ninth graders. So that's a quick sweep, but at each one of those steps, it's not like I've left behind any one of those ways of interacting with agent-based models, but they have really different benefits. So the engagement and immersion and social dynamics of the augmented reality case are really different. Like, they're not better, but they're just different. So kids, the designers spent most of their time really focused on how they could create a feeling in their participants, what it would feel like to be the character in the different settings. There was a lot of dynamics between the kind of the social system that is a classroom group and trying to map that onto the system dynamics of ecosystems. And then the last thing is it was just remarkably easy to get ninth graders to dive in as designers. I've tried to get people to make agent-based models through coding, and it works, but it was not nearly as easy as it was to get people to say, let's try something out with our bodies and see if we can make code that that brings this aquatic ecosystem to life. And that was true even of the participants, that they wanted to stop the activity and change the code, where in the case of the disease part sim, people would stop the activity and change their behavior, but they didn't really get into changing the underlying code of the simulation. So I think it's promising in a kind of quiver of other ways of getting at systems thinking with younger kids.